In this lesson, we are going to learn how to write chemical formulas from given names. The first type of name that you are going to see is a single element metals. And when you see a single element metals, you're going to use the element symbols on the periodic table. For instance, we have calcium. The element symbols for calcium is Ca. So the formula for calcium is also Ca. Sodium is Na. Potassium is K. Aluminum is Al. Lithium, Li. Magnesium, Mg. So again, when you see a single element metals, use the element symbols on the periodic table. Another common type of substance that you are going to see is ionic compound, which consists of metals and nonmetals. Now, ionic compound naming does not use prefixes, so we have to use the crisscross method to balance the positive and the negative charge. In this case, when naming ionic compound, the first element is always the positive metals, and the second element is always the negative. So here we have vanadium. That Roman numeral 5 indicates the positive charge of 5 plus for vanadium. So if we know the symbol for vanadium and there's 5, so that would be 5 plus. We don't have to look at the periodic table for the charges. And then phosphate is a polyatomic ions all the way over here. PO4 3 minus, so we have PO4 3 minus. Now to balance out the charge, we're going to crisscross and carry the number only. So crisscross numbers only. In this case, we crisscross and we carry down the 3. That 3 represents there are 3 vanadium. So we have V3. Now that 5 is going to carry down to represent the number of phosphate, which is 5 phosphate. But phosphate is a polyatomic ion, so we have to use parentheses to group the polyatomic ions together, and we have PO4 parenthesis 5. The next thing we have is sodium. Now sodium does not have Roman numerals, but we know that sodium is in group 1A, therefore it has to be 1 plus. So Na 1 plus. SO4 2 minus. And here we go, we do the crisscross to balance out the charge, which give us Na 2, and we have SO4. When we crisscross down, we don't have to use parentheses. The next one is ammonium nitrate. Ammonium is a positive charge polyatomic ion, which is NH4 1 plus, and nitrate, going back to nitrate, is right here, NO3 1 minus. Notice the positive and the negative cancel out, so we don't have to do any crisscross at all. We can just write NH4 NO3 without using parentheses to group the individual polyatomic ions, because there is only one of each. Then here we have calcium chloride. Calcium is in group 2A, so therefore it has a 2 plus. And chloride is in group 7A, coming from chlorine, there you go, which give us Cl1 minus. The charge is not even out, so we had to crisscross. The 1 will give us 1 calcium, the 2 will give us Cl2. Another type of substance that you will see is covalent compound, which consists of nonmetals and nonmetals. In this case, the electron is not transferred to another atom, so we have to use prefixes to indicate the number of atoms. This is a lot easier because the name tells you exactly how many atoms of a particular element is going to be. Here's the naming structure. The first elements use the element names on the periodic table, but it does not write the prefix mono when you have 1. However, for the second element, it uses the anion's name. Here we have dinitrogen monoxide. And here's our prefix. The prefix di represents our 2, so we have N2. And then we have monoxide, which is mono is 1, so we just have O. When it's 1, we don't have to write anything. The next example is we have carbon dioxide. Carbon, there are no prefix there. That tell you it is mono. So therefore it is C. And then we have dioxide, which is two oxides from oxygen, so it's O2. And then lastly, we have carbon monoxide, no prefix, so we assume it is a mono. Therefore, it is C, monoxide, it is CO. And lastly, we have another type of substance. It's called single element gas as diatomic molecule. Think of the prefix di. That means there are two atoms molecules. Okay? So here we have hydrogen bond with another hydrogen. It would make H2. Here I have hydrogen gas. It is the same thing. The only thing extra it is just that one. So we have to assume that this exists as a gas form because it is extremely unstable by itself as a single atom. Then we have bromine would be Br2. We have chlorine gas, the same thing as chlorine, would be Cl2, and nitrogen would be N2.